is some sample data. I had a conversation with Ethan. He hasn't joined yet. Ethan Port wrote some of the curriculum for the Salesforce DataWeave stuff. So what I'm going to do, I'm going to put the actual meeting up on my other screen. So when I'm talking to you guys and looking at you, I'm going to look up there and don't be weirded out by that.
Okay.
This class, I'm going to have to hit preview on it. I actually made some files for it. How do I do that? Course.
I know, Ryan, I tried to get those files downloaded because I was just going to hand it to him in the class, and I couldn't locate the files.
Do I have to publish? I might have to publish. So I'm glad you said that. I actually have been making new versions of the files over and over again. So you guys are getting to see the internals of our learning management system as we figure out how to use it. First of all, how do I get in here? I think I have to click on that. I want to go into challenges. Where's my lesson? See, I made a lesson for this and I wrote all this nice stuff. Oh, I have to expand it. There it is. And I'll edit the lesson. And where's my attachments? See, there's my attachment right there. So, so this is the sample customer data. I had a conversation with Ethan. Oh, he joined. Good. And welcome, Ethan. And he made a comment that he had been talking to someone and they're like, why do you ever need recursion in DataWeave, especially tail recursion? And I was like, well, and I started thinking about more when you actually need it for real work, for real integration work. And so this whole thing, I ended up spending way longer preparing this study group than I usually do. And I made some sample data and I got a bunch of code to show you guys. I got some goodies at the end. It's all DataWeave related stuff.
Good.
And I challenge you guys to go off on your own and start from scratch, not from my code, and try these little challenges on here. So the sample data looks like that. If you logged into the meeting, you should be able to get it. I'm going to go to the preview screen now and see what it looks like. Yeah, it should. So I'm previewing the meeting. It says there's a downloads at the right side. So I don't know, Diane, you want to share your screen? I don't. Somebody who's logged into it. Is anybody able to get the download?
I am looking now. I'm still not seeing that. Can you hear me okay? I'm still not seeing the download myself.
Can you get to this whole screen? This
lesson? No. Oh, you're under challenges. Okay. Well, maybe I need to go to challenges. Hold on. Challenges.
Dan, left side.
You want to share your screen, Jahnavi, because we're learning our learning management system right now. So if you want to share and show it.
I found it. Yeah.
So it's on
Jahnavi,
the recording.
do you want to? Are we recording?
Yeah, I wanted to show on the recording how to get.
All right, hold on. I'll do it real quick. One sec. Okay, so I was actually under, when I first came in, there is the DataWeave, the upcoming, advanced pattern. So when I'm on this module, there is a category underneath called challenges. And that's where
do you have the download?
Found. Why did that just do that? DataWeave. Nope. Okay, I did it wrong. Hold on. I did it wrong.
I probably organized the class in a confusing way, but let's figure it
out. Yeah.
Because
okay. It's on this page, Ryan.
Oh, it is?
Of challenges. And, well.
Go into that. Yeah, click.
Okay, there it is.
There it is, yeah.
So what I'm going to do, I'm going to download it. And then if anybody has a challenge getting to this, what I'll do is I will put it, I don't know if we can add it to the chat of this meeting, but I will put it, will it?
No, it's supposed to, there's the way this meeting shares files, you just found it. So if it, hopefully it's just a navigation confusion.
All right. Anybody in my class, I'm going to go ahead and shoot it to you in the Zoom.
Okay, that's cool. Works for me.
Okay. All right, I'll stop sharing. All you.
Yeah.
So welcome. There's a couple other people too. We got to say hi to Harnath is here also. Jahnavi, of course, too. Or Jahnavi, great to see you here. And hey,
Brianna.
Hey, yeah, Brianna also. Yeah, good. Yep. And Evan, I still need to get with you on Object Store. I haven't forgotten. I promise.
Right.
Next week.
Sure, no rush.
Yeah. So let's look at our data. So the first thing, I made a DataWeave library to generate this data. and it's on our GitHub. So if you want to see some recursion, I'll actually show you that. I used recursion to generate the data in the first place. So integration quest, GitHub, there's a repository, DataWeave.data generator. And this is where the work I've been doing is in. And I did a bunch of stuff that's unrelated to what I want to do in the study group, like log normal distributions and statistical stuff, because I wanted to generate some pretty realistic data. But I like this because it shows you what the sample data looks like. It's an array of customers, and customers have IDs, and customers have invite codes, and customers have referred codes. And some of the referred codes look like an invite code for a very good reason, because they were invited by somebody else. And other referred codes look like that because this is like a cold sign up. So the whole idea of the example is like people signing up for our website, and we want to figure out who referred who, right? Now, to get this to work, I got to give some credit. I did use the MuleSoft mock data generators, which is kind of a neat Easter egg in this study group because it's a DataWeave library. I can just click on this. I'm going to have to rewrite it without this, and I can explain why at the end. But MuleSoft published this about a couple of years ago as just an example DataWeave library, but it allows you to generate like first names, last names, addresses. So I kind of used that to make customers who refer to each other, right? So that gives us a data set now that you downloaded, where this is where it came from, and the data set looks like these kind of numbers. So the idea of the exercise is, all right, let's go figure out who invited who, right? Let's ask some questions about that. What I want to start with is a very simple DataWeave function, and I'm not using. I'm going to show you a couple things. I'm not using Visual. I have 3 different editors going on right now, and the reason I'm not using Visual Studio Code, even though Visual Studio Code is definitely my favorite editor for DataWeave, is for some reason Visual Studio Code doesn't like to read data very fast. So when I use Mule, it can extremely fast read files and write files, like a couple milliseconds, a couple hundred milliseconds, like super fast. Same computer, same laptop. When I use Visual Studio Code, it took me 2.3 seconds to read a 500 row file. Now this is I'm using a library from DataWeave core called timer. You can use duration function that MuleSoft provided, and it times your DataWeave code for you. So that means 2,393 milliseconds to read. That was the last example, to read a 500 item array out of a JSON file, which is silly. That's way too slow. There's something going on with Visual Studio Code that I haven't figured out. So the second way I like to edit stuff is in, of course, the DataWeave playground, right? And I'm not going to do that here because my data that I want to play with is too big. So DataWeave playground has limits about how big your inputs can be. So we could try, right? I could open up, let's go do this. I'm going to try my 5K file. So I've got 3 files I created here, a 500, a 5,000, and a couple different 50,000 customer files. Those took like 10 minutes. And I'm going to open one with, here's Sublime Text. So this is 5,000 customers. And let's just see what the playground does with that, which I don't expect it to be very good. But let's try. Customers 5K. But I haven't tried this. This is live right now for the first time in the study group. Boop. Okay. All right. And let's see what it says. Customers 5K. Let's do size of that and see what happens. Uh-oh. It's not too happy with me. Of course, that's only the 5,000 customer file, and it's not good for the playground.
You already broke it, Ryan.
I'm surprised you can load that many lines into the playground. It truncate. There's a limit to the total number of characters you can have.
Yeah.
Did it truncate it, or did it get all of it?
I don't know what it did. It broke anyway. And when I was just the last 2 days, I only used the playground for about 30 minutes, and I decided that wasn't going to work. So I ended up in Anypoint Studio using Mule. That's where we are now. And I'm not going to show my solution for rank because I do think it's fun to build it together. So I did a bunch of different functions. The ultimate one that I haven't done yet, and if we have time in the study group, we can do together. This is the one that inspired the whole thing based on our conversation, Ethan. If I have 50,000 customers and I need to insert them into a database with a foreign key constraint or a Salesforce or something, I have to put the guy who referred you in before I can put you in. Otherwise, the external key won't work, right? And I ran into this in real projects. This isn't like I'm making it up for this. That's what inspired the whole thing, is you have to have some way to put the ones who invited before the ones they invited. So they get inserted first. So the ultimate goal of this whole challenge would be build a resequence function, right? Where it takes a big collection of customers and it puts the inviters in before it puts the invited in. But it's all the same algorithms based on the same idea. So I'm going to start with a live. We're going to do this live. We're going to put a scheduler in here, and I always change it to 1,000 days because the study group's only like an hour and a half long. So that's only going to run once. And this is going to be the live rank flow. And we're going to have to use transform message, even though usually I would rather do this in Visual Studio Code. And I lost my second monitor, but that's okay. I don't need it anyway. And we're going to read. This is right out of your sample data. The 5K file first. Customers 5K.json. So if you're following along, I'll challenge you. What I want you to do is write a rank function, right? So what we can do is rank a random customer, right? And what rank means is if you came into the site with directly, like nobody invited you, your rank is 0, right? If you were invited by somebody and their rank is 0, then your rank is 1. So if you were like invited by somebody who was invited by somebody else, who was invited by somebody else 4 times, your rank is 4. So we're going to make a function to figure out your rank, right? Yeah, graph to the rescue. That's exactly. They do these inside. So we're going to go read our 5K file. Customers 5K.json. There we go. And I've rehearsed this part. This is super fast in a Mule application, but I did find out that it's always helpful to have a logger at the end because you're not sure if it ran or not otherwise. So put a logger at the end. And what I'm just going to do is log the payload at the very end and make sure that my transformation gives me a short output, right? So we're going to just get rank. So we want to do, how about like ID is going to be a customer ID. So I'm just going to make a variable called ID, and rank is going to be rank. So we're going to need to define those two things. I guess first, let's go get a customer ID to start with, right? So I'll just do
Ryan, are you recording, Ryan? Because I don't see recording anywhere.
Oh, yes, I am. It says stop recording up there on my other screen.
Okay, perfect. I'm not seeing that. That's cool. I just want to be sure because I didn't want to miss this.
Now, I do a lot of typing stuff, right? So I made a little DWL file here. You can see it. I made some types for what the data looks like. I'm holding off on that because this is more about recursion than on typing, but my preference is to definitely use types everywhere, with including type parameters like array of customer. But that's not what this session is about. So I'm just going to do a cold array like that. You could even say array of any, right? But I'm just going to use an array here. And we're going to say var ID is equal to customers random int size of customers, right? So I'm going to get a random customer dot ID, right? And let's at least see that work. So we know at least the flow works.
If anyone has any questions along the way, just either put them in the chat or go ahead and come off mute and talk to us.
No, it didn't like that. It says the file doesn't exist. which makes sense because I have a hyphen in my file name. So no, it doesn't exist. So let's fix the file name. Customers hyphen 5K. Save.
The best part about doing it live
What is?
is having hiccups along the way.
Oh, I had some crazy hiccups that I'm not even bringing in here. So there's a customer ID, right? That's found it in the file, right? And I even sometimes when I was concerned about performance, I put a little logger at the beginning just so I could see, you know. So like this would be like started, and I can see how slow things get when you start doing recursive functions. You do need to start worrying about performance, and I'm going to show you one very soon that is very tough to make good performance.
Yeah.
So we're going to get rank now. So rank is rank of ID in customers. So I need a function where you give it an ID and you ask the customers array what its rank is, right? So we're going to write that function and think about how we might write it. Fun rank of ID string customers array. I'm holding myself back on these type parameters. We're just going to do array, not array of anything. Is equal to, well, what's it equal to? Now, remember the rules on rank. So how are we going to, any ideas? Put in the chat. How do we determine the rank of this ID?
It's actually based on the lowest number, right? Well, you just want the rank, correct?
Yeah, and the rank based on invites. So remember, if you weren't invited by anybody,
You're at 0.
so how do we know if you were invited by anybody? And I'll show you the data again. It's not just call center. Good call, but I made more than one. Here, I'll show you. I'll give you the inside scoop on that.
Invite code not equal to null.
Well, there's no nulls. These are my 3 what I called cold referral codes. But I don't think we should check for those. I think we should check if anybody in the array invited them. Because later, remember, when we do the resequence part, we're going to need to check if anybody in the array invited. So how do we see if anybody in the array invited this ID? And I'll show you the data again.
It has a referred value, like a random value, not one of those predefined values.
Yeah, and not only that, it's not one of the predefined. Somebody in this referred code has to be found. Some other item in the array has to have that invite code, right? You want to go find you have to find the other row where the invite code matches the referral code. See how this matches this? So this guy's invite code is different, right? So if your referred code matches somebody else's invite code, then they invited you, right? So what we're going to do is group by would be, I see there's a suggestion in the chat for group by. That's a good way to find all of the people that somebody invited, right? If you wanted to say, how many people did so-and-so invite? Here, I want to just go up the chain, right? So I'm going to make a do function. We're going to do. So that way I can define a local scope, right? Var parent equals something, right? And if parent is equal to null, if there's no parent in the array, then we're going to return 0. If no parent in the array, my rank is 0, right? Else we're going to have to do some other logic, right? And when you build, we know this is going to have to be recursive because you have to find out the rank of your parent in order to find out your rank, right? So let's start out with, whenever I do recursive functions, I got to start with this base case, the simplest, the one that doesn't recurse, right? So 0 doesn't recurse. So how are we going to, first thing we got to do is find your parent. So I'm going to use the arrays module because, oops, that's not what I wanted. There we go. DataWeave. I'm going to use the arrays module, it has a way to find an item in an array based on a condition. So give me the first item in this array that matches X condition. Otherwise, give me null if nothing matches. That's kind of what I need, right? I need to say who invited me, right? So the first item in the array who invited me, that's the one I want, right? So let's go make that. Referred in a record. There's a question in the chat. Hold on, let me go back here. Referred in a record means who I referred to, and that user will be using the invite code. Right now, I think that's reverse. Referred means who referred me. An invite code is what I use to invite other people, right? So if Paola was referred by this invite code, right? And Mitzi has the invite code. So Mitzi is the inviter, is the person who invited Paola. See? Because invite code UNH whatever matches referred here. So we're going to go find it. Right? So the parent is customers first with, and you can, I like to define my parameters of my lambdas here, and I have an issue. I don't have first with, so I'm going to go get that. Import. I'm just going to directly import it for this time. There we go. So we're going to get first with. And if you don't know about this question mark thing, this is an actual token in the DataWeave language parser that makes errors go away. So if you don't have the question marks, it does that. So I use the 3 question, and it is 3 question marks. See, if you use 2, 3 question marks is a magic token that makes the language parser happy while you're not done yet, right? So we're going to do that. We're going to get the first one. So I want the first customer who c.invite code. Oh, equal something, but I need my invite code first. So I have an ID here. Oh, so we don't have the actual customer record. We just have the ID. We better get it. So var me equal customers first with c.id equal ID. So now I've got me, and I'm going to need another layer of do here because I might not be found either. So that's actually the super simplest case. So let's comment that out for a minute and comment this out for a minute and just handle the case where you give me a wrong ID, right? So if me equal null, we're definitely going to be ranked like something weird, like -1. If it's not even there, it doesn't make sense, right? Or I could make the result a union type number null. I could return null for, but I'm just going to do -1 here. How you want to design that is a good question when the person isn't found. Else do, and then we do the rest of that, right? So let's get this out of here. And like that. And then we'll do the rest of that logic we were already talking about inside the inner do. Boop. All right. Oh, I guess I should uncomment it. So now we know the ID exists. We have the customer, right? And the parent is going to be the first one where the other customer's invite code is equal to me.referred, right? Now I have my parent, right? And if there is no parent, my rank is 0. Now, if there is a parent, what's my rank? You're 0 if you haven't been invited by anybody. If you have been invited by somebody, what would make your rank 1? You'd be rank 1 if what? If your parent was rank 0, right? So if your parent is rank 0, you're rank 1, right? And then if you invite somebody, what would their rank be?
2.
Yeah, then they would be 2. Yeah, and if they invite somebody, that's 3, right? So you need to add 1 to the rank of your parent. And the beauty of recursive programming is that's exactly how the program reads. 1 plus rank of parent.id customers, right? My rank is 1 more than my parent's rank. Make sense? Does that read right to you? You want to try it? You want to run it? Always run your code and see. Here we go. Let's see what it does. Okay, apparently this ID is rank 5. So this ID, whoever that is, was invited by somebody. Let's go look and see. So we're going to find this ID. Uh-oh. Looks like my text editor is a little... Here we go. Let's try this again. Huh. Oh, I pasted a bunch of DataWeave code. That's not what I wanted. I want to paste this. So we're going to go find this person. There they are. So Honorina Preexens or whoever was invited by this 81G person, right? So we're thinking we're going to check and see, is this person rank 5? So let's go find that person. Boop. And that's Erhan Bonina, who was invited by this person. And that's Farouk Erdman. That's 3, right? And Farouk was invited by this person. That's Janina Vilok, who was invited by this other person here. Let's find that one. That's Loria Kuman. I don't know if we already got to 5. Oh, 5, but it's 0 based, right? So let's try one more and see who about this person. Aha. Apparently, oh wait, that's somebody else who was invited by them. Referred. I need to find who was invited. Oh, there it is. Said Cedro, the very first one. Look at him. He was invited by the call center. So it worked. We got back to Saeed. He was the originator of all these people. He invited somebody who invited somebody who invited somebody who invited somebody who eventually invited Honorina Prixens, who we found randomly, right? 96,000 lines down in a file. So Honorina's rank is 5. Any questions about how we came up with rank here? Make sense? Clear? Yeah. You want to do something harder? All right. We're going to do something a little harder. What that thing I just did in the text file where we tracked somebody back, what if we wanted code to do that? So I called that one lineage. What if we wanted to find somebody's lineage? Who invited you? Who invited you? We could see the history of the invites for somebody, right? Another way I could go, we could also try it on the bigger file and see how long it takes. Let's try that. I want to do that real quick. I want to do one and see how long the bigger file takes. And then we're going to do the lineage for somebody. All right. So we started at 11:34:00 Central Time, United States. Doesn't say Central Time here, so I added that time zone context. And it's just taking a minute. So why do you think it's taking so long? I did a test on this and I found out. Any ideas why the 50K is slow? Look what the function does. What would be slow? It's only what? 12 lines of code. And look how hard my computer's working. Okay, good. We found this person, rank 6. And it took my Apple M3, right? Is it busy still? Oh, I still have another process been running since this whole time that we've been. That's my fun thing for later. I've had this process running for a long time. So DataWeave can use a lot of compute, right? That one took 36 seconds for this 12-line function we just wrote. So what would be slow about this 12-line function? And we need to go back to our computer science days. it was a lot slower for 50K than 5K, right? Let's try that again and measure it. So we got 36 seconds for 50,000 records. And let's do 5K and see the difference. So the size of the input is impacting the time it takes to compute something. Does that remind anybody of any way of thinking about that? How do you look how long this one took? 5,000 only took less than 1 second, and 50,000 took 36 seconds. 50,000 is 10 times 5,000, right? I was doing some Excel analyses of this, not that one, that's something else, on a different project. And let me show you some graphs. If you have processes, some processes, when you give them more data, they scale like that. You see that? Other processes, when you give them more data, they scale like this. What do you notice about the two lines? There's something very different about those two lines. You can easily tell by when you project it out, right? Look how far that blue one goes. It's up to like 50 seconds with an input of 400, and the orange one is down here at like 6 seconds with an input of 400. Right? So down at small amounts of time, they seem pretty close to each other, right? But the more inputs you give, the worse one of the algorithms does. That's complexity analysis. This is big O of n squared. So they call that big O notation is a way of describing the blue line is n squared and the orange line is n. Somebody's who? Go ahead. Who wants to jump in?
No, I was trying to understand when you said big O. Are you talking about the recursion time complexity as
Yes.
it goes smaller log n? Okay.
Yeah. So let's look at our function here. How would we think about big O notation with DataWeave? Why would it matter with DataWeave? Well, sometimes we have large data sets, and sometimes we have small data sets. And when we deploy our code to production, sometimes you're doing an ETL job, and most of the days, like maybe weekdays, the job is this big, and on weekends it's really big, right? So you have input that's variable size, and you wonder why your job takes way longer on the weekends than it does on the weekdays. So big O time complexity matters for integration when you are doing an algorithm that needs to figure out, like, that needs to transform the data in a certain way, right? So you can do algorithms, you can create algorithms for regular business transformations that have good complexity or bad complexity. You can end up with the blue line or the orange line in your DataWeave. And I wrote something here with the blue line. This is O(n) squared. Where's the functions that are taking time? Think about what this has to do. When it starts, the customers array, this was much slower when customers array had 50,000 items than when it had 5,000 items. So you see any steps in here that would be slower with more items? What does the computer have to do for line 10? Let's start with line 10. When I run line 10, what is it going to need to? What is the DataWeave runtime going to have to do to execute line 10? Like if you were going to write the first with function, you would have to do what? You'd have to check the first item and see if it is true or false, right?
Yes.
If it's not, then you check the second item and the third item. So in order to run line 10, it's going to have to run what we call big order of n. It's going to have to scan the entire array to find the ID, right?
Yeah. So it's go from, but if the element is in the first or the second one, then it doesn't have to go to the order of n, right?
It's order of n still. It's just order of 0.5 n, right? Because on average, it's going to be half of the,
Average.
you know,
Yeah,
average.
okay, average makes sense.
Yeah. So you'd go with n because half of n is not much better than n. It's the same problem because you're multiplying. This is why you care. You throw away the constants in big O of n because you're going to end up multiplying things. And half of n times n is just as bad as n times n. Right, so we're going to have to find this one time. This is O of n executes one time only, right? Wait a minute. No, it
So
doesn't.
if the ID is already present, then don't call it again.
I would love to do that. Yeah, we might be able to cache something and have a smaller lookup, right? And then for this one, we're going to have to, again, scan again for the parent, right? We got to go find the parent of this guy, right? And then we're going to have to do that same activity as many times as the rank. So if you're 7 deep, then you got to do 7 times. You have to scan the whole thing for number 7, then number 6, then number 5, then number 4, then you're going to run this every single time over and over and over again for the parents, right? So this part, this recursion part, the fact that we loop is going to be on average however deep the data is. So if the whole data set was rank 0, then this would be fast, right? Because nobody invited anybody. Everybody was rank 0. We found everybody on the first try. So wait, not this one. This one, right? If no parent is in the array, my rank is 0. And if everyone was rank 0, no recursion would ever happen, right? And if no recursion ever happens, then this whole thing would be fast. It's only when we find somebody who is not 0 that we have to go again, right? So the deeper our data is, the more recursion we're going to do and the slower the algorithm is going to run. So I made some examples to make it, you know, better and worse. In your sample data, there's a 50,000 that's kind of shallow. It only has up to like 5 or 6 or 7 invites. And then there's a deep one. And I spent the morning making it deeper and deeper. I think I got it up to like 40 or 50 invites deep. So you can you can try to see how your algorithm works when your data is shallow or deep with 50,000 rows, or you could sample, right? If you wanted to practice, when I'm working on on things that are slow, DataWeave is functional, so you don't get to log while it's running. You only get the logs after it's all done. So what I would probably do is take, you know, 500 out of the deep one at random and run it on those, right? And then see how it works with 1,000, see how it works with 2,000. So you can kind of scale your algorithm up without, you know, having to take a coffee break every time you run it, right? So you have different samples here to work with, right? But it works. We have our rank figured out. So let's do our lineage one. I'm gonna get rid of the scheduler here and make a lineage flow. So live lineage, and we'll make this one run very infrequently. Put a little logger to start it. And just any predictions, put in the chat. Do you think the lineage function, that's going to print out all of the different people that invited you, do you think its performance is going to be very similar to the rank function? I'll put that in the chat. Or do you think it's going to be slower or faster? So how will performance for lineage function compare with rank function? Predict. You're going to make a prediction and you're going to think about how would a lineage function need to work, right? So we're going to put started. We're going to read our file. Customers, we'll do the 5K again because that's going to be fast. I forgot that one. I also misspelled. It was only in a comment, but still, I'm a little buttoned up sometimes. And at the end, we're going to log the payload. And in the middle, we're going to go find out our lineage. So lineage for a random, how about for a given customer? So who did we get last time? Let's get this one, whoever that is. I think we found that person already once. So this time we're just going to start out. We're not going to have to find a random one because we already know one. Var ID is equal to that, right? Oops. And we need to lineage of ID customers, and I guess I need a customers var customers payload as array. There we are. So let's write this lineage function. ID string customers array, right? And it's going to return an array of objects this time. It's going to give us back the customer we asked for, and then that one, and then the parent, and then the parent, and then the parent. And we can decide if we want which order we want it in, right? Anyway, it's equal to, now we already know the beginning of this one. It's got to be the same, right? So if, actually, I don't even need a do for this part. I'll probably use a do. Var me is equal to, I better get my same thing as last time, right? Import star from arrays. There we are. Customers first with all right, we're going to find the customer with the given ID. Was the one I just grabbed? Yeah, that was from the 5K. You can tell because it only took, part of a second. Yeah, so that'll be in this file. Good. All right, so we've got the customer, and if there's no such thing, right? Me equal null. Now, in this case, we shouldn't return -1. What should we return if the customer is not found? How about an empty array? All right. If you don't find the customer, you shouldn't, there's no lineage, right? No lineage would be that's a much more natural thing. Else do, let's find the parent, right? Customer. Now, what I found for performance is we can do better than order of n for finding this person. We're going to have to keep looking people up by invite codes. So we would like to have a faster way to look people up by invite codes by pre-caching them. So what I'm going to do is I'm going to create an invite lookup object. Objects, and I tested this. I have proof from the playground. Objects are much faster to scan than arrays because there's a log n lookup for an object. It's a hash table, right? So we're going to make an object here. And when you want to make an object out of an array, that's your DataWeave syntax for that. Of all of the invite codes and the customer who the invite code refers to, right? So we're going to look customers map to an object. And the object's going to have a invite. Oh, no, it's just going to be made up of c.invite code, right? :c. Now, what's it upset about? Type any cannot be used as a key. Okay, as string. We'll just force it. It better be a string. All right, so now we're going to have an object where the keys are the invite codes and the values are the customers. And this is creating an object to improve performance of invite code lookups over array scan. All right. So we'll do this. Now, instead of scanning customers, I can use invite lookup of me.referred, right? So if my referred is in the invite lookup, then I've got a parent. And just like last time, if parent is null, the lineage should just have me in it, right? I'm the only one in it. Expecting type object, but got any. Well, whatever. Me as object. When I'm using my type system with customers, it works a lot better. Else, what we want is what? If the parent is not null, we're back to the same boat as the rank, right? What do we want when the parent is not null? We're going to want to have an array of all of our parents, right? And we know who one of our parents is. We know who our direct parent is. So we want to put me into the lineage of my parent. Don't we? So we're going to prepend me first. Me as object. Again, there we go. We're going to prepend this operator puts an object at the beginning of an array, right? So we're going to put me as the object to the front of the lineage array that my parent has, whatever that is. And it's going to go loop again. It's going to go through this whole process until it finds my parent and then his parent and his parent. Let's see. You want to see? Let's see if it works. Now I rehearsed, so I'm pretty sure it's going to work. But I did code this live, and it's possible we'll have bugs. Let's have fun with it and see what happens. So we're going to run lineage for the 5K thing on the same person we found the last time. Oh, looks like it worked already. Let's see what we got here. So this is the ID we just got, which I don't remember that name, Araceli, but anyway, we found that person. They were referred by this invite code, which is Silvana Grunick, right? Who was referred by this invite code, which was Elisenda Wiedhoft. I don't remember any of these names, so we probably got a new one, right? Elisenda Wiedhoft. And that person was referred by this invite code, which was Rosel Donas, right? And that person was referred by this invite code, which is Loria Kuhlman, who was referred by our same original guy, Saeed Sidro. He's the call center guy. Right? So we've got the whole lineage of somebody, 1, 2, 3, 4, 5, 6, in a function. Right? And recursion often feels like that. It's not very much code inside the function, but the call to the actual function, when you go back to the top level, that's where all the magic is, right? So we're going to climb up the hierarchy with the lineage function. So we've got 2 of those. What I got on my notes here. Any questions about lineage? We might have time for my actual sequencing thing. I put that on my notes as like the if we have time function, because I got something special to save for the end. I'm going to show you how to be DataWeave wizards, and I'm not joking. That's not the that's an actual thing. You guys want to be DataWeave wizards? If not, well, anyway, wizards have to cast spells. That's the trick. I'll save that. All right. So there's that's like 2 examples of pretty like standard recursion functions. Now let's do like the one where you actually would need to do it for the project, right? So we're going to read the file, customers 5K, and this one I haven't done yet. This is a live. I'm gonna have to figure this out with you. Live resequence. So we're going to read the file in from the desktop, and what we're going to try to do is put Saeed before anybody that he invited, right? And then we're going to put Luria before anybody that she invited. And we're going to put Roselle before anybody that she invited. And that way, when we insert them into Salesforce or when we insert them into a database or something, the rows that need to be referred to, which is the inviter, they're already in the database before the children get inserted, right? So let's figure it out. Here we go. We'll do the same thing as before of our customers equal payload as array. All right, now to sequence the customers, I'm going to have some way. 5,000 customers are just going to fill up my log file. So probably what I'll do is take the resequenced customers and then map them. ID, or custom, or here we go. So I can put them in a CSV file and open them in Excel. It'll be a lot easier to see it. Customer c.id, invite code, c.invite code, referred, c.referred, and maybe sign up date. Oh, I guess I should have the name, huh? Yeah, let's put the name. I like that DataWeave lets you leave a dangling comma on the last line. Makes it a lot easier to resequence stuff. So first is c.name.first, and I've just worked with I made the format, so I remembered that. I didn't have to go look it up. And last is c.name.last. Good. So now I'm going to have an array of objects. Fun resequence. Customers. I know I'm gonna. This isn't the final version of it, but this gets it to compile anyway. Resequence. What am I doing wrong? It doesn't like something on this line. Oh, I need a comma here. There we go. All right, we've got kind of our framework here, and I can output the whole thing as CSV, and then we can, instead of logging it, we can just say finished, size of payload. There we go. And now I can like go write it to a file so we can actually look at it. /sequenced.csv. There we go. That should work. And I need to read it. Is it read in JSON already? Yeah. When I read it, I want to use MIME type JSON, so it knows it's a JSON. And we're going to resequence here in DataWeave. All right. So what we need is we need to put all the people who are rank 0 before all the people who are rank 1. Actually, I don't exactly have to do all of them. Just anybody who shows up and we haven't already seen the person who invited them. Yeah, I'm gonna have to do this tail recursive, even though that's the only way I'm thinking about it. I'm gonna have to pass some more parameters in. We're gonna need to do sequence. So this is done, which is gonna be an array. We're gonna pass a done array in, and I'm using default arguments, so the call doesn't need to use it, right? So if something is in the done array, I think I want an object because I need to check if things are in there, right? So done can be an object. There we go. And we'll just, the nice thing is DataWeave keeps objects in order. So all the ones I finished are going to be in the done object. And that's cool. I can use customers as the not done object. So at first, everything's not done. And then as I do things, I can remove them from that, right? So now I just need to take everything out of customers where rank is 0, or, so I'm going to need the rank function, right? Where rank is 0, or my parent has already been done. That's probably enough. Yeah. So first thing is if is empty customers, then we're just going to return done. When you do tail recursion, that's usually instead of returning an empty object, you return whatever the accumulator thing is. So we're going to do done there, and then else do. Now we do the actual function here. Now, if it's not empty, we got work to do. Now we need all the items. We could do one at a time, actually. So we could just deal with the first one and then recurse, right? But I think there's a nice function in arrays that I like to use here. Arrays has a nice function, take while. and another one drop. So take while says, give me all the items out of the array from the beginning, as long as a certain condition is true. So I can take all the ones from the front that match, and then I can drop them so that the new array doesn't have those in it anymore. All right, so let's do this. Var ready is equal to customers. I'm going to have to import star from DW core arrays. Customers take while something, right? Which we're going to have to figure that out. And then var remaining is customers drop size of ready, right? So the next recursion, I'm going to pass remaining into the customers. I'm going to add the readies to the done. That's the whole algorithm, right? So we did this logic is remaining to do, but I guess I could do the recursion now. So resequence remaining, and then var next done is equal to something. So I've got to add those readies to the done thing properly, right? So I have to accumulate that remaining and next done. And I wanted to show you guys, what is this saying? Invalid input line 7. It doesn't like this. Oh, there we go. Oh, right. If it's empty, done is an object. So I have to do done pluck value key value. Give me all the values of done, the customers that are in there. Because I used an object instead of an array. Good. So I wanted to show you there's an annotation. When you want to use tail recursion, there's times that you need to, and there's times that you don't care. This is one of the times I don't care. If I knew I needed tail recursion, which I don't know if I'm going to have time in this session to talk about, there's an annotation tail recursive that makes sure that your code is compatible with this thing tail recursion. Tail recursion means that the whole function does all the work before the call to the recursive function. So everything's sorted out first, then you recurse. That way the engine can turn it into a more efficient execution path. It doesn't have to remember things as it goes. So we're going to pass everything forward into the parameter list. And that's tail recursion. So I got some things to fill out here. I think that the most important part is this take while. I want all the ones who have no parent. So customer. Whoever, if they, so they're ready if they have no parent or if their parent is done, right? That's who's ready. If you have no parent or if your parent is done. So I'm going to need to know who the referred is. Yeah. So the hard part is the no parent thing. So first, if they're done, the done is going to be a very easy check. It's going to be low compute. It's not very costly. So first I'll check the parent is done part. So that means done square bracket customer.referred question mark. That means, does the referred key exist in the done table already? If it does, we're done, right? Or now I have to do the actual check. Now I have to see if this person has no parent. So this is the costly part, right? Customers sum. I know that's an unusual one. Sum is a function that just checks the whole array to see if anything's true or false. And in this case, I need to check the whole array and make sure they're all false. So I want not sum, like none of them are true, right? So not customers sum parent dot invite code equal customer dot referred, right? So this means no parent. And this means parent is done, right? So we've got both cases figured out. So we're going to take all the people who we're ready to take, right? And we've got this weird case where there might be nobody ready, right? And this is trouble. If nobody's ready, we're going to recurse forever. So I need to check that. Oh, I need to check that. I need to basically put the first one at the end of the customers array, if that's the case. Actually, I could just do that now. I could do that always. That doesn't matter. So it doesn't only matter if there's nobody ready. I can always take the next customer who I know is not ready, right? So let's do that. Var next remaining gets if the next customer is guaranteed to be ready, to not to be ready, because I already removed them all, right? Oh, I'm already doing that. Okay, so I'll just do it here. So I'll take this customer's drop size of ready, and then I will drop one more. For our next rotated, I'll call it that. Rotated remaining gets if not is empty remaining. Actually, if it is empty, it's easy, just like that. Else, I need to take the first item off and put it at the end, right? So how can I do that? I think, yeah, it would be like this. Remaining drop one, right? Take the first item off and then put it back on. Remaining square bracket 0. So now we're going to take the first item, stick it at the end, and then this rotated remaining is going to be sent down the path. All right, good. So now we're going to make sure that it's possible the next one's going to be ready when we recurse. Almost done. We still need to put stuff in the cache. We never put anything in the done cache. So the next done is everybody who's in ready. So done plus plus an object. Oop. So ready map customer to an object c dot invite code customer. Oh, I got to do that same thing as before, as string, right? All right, so we're going to now make the object have all of our invite codes in it. Now, normally, if I wasn't here with you guys doing this live, I would be not having been practiced this already. I've been practicing this for 2 days. I would have stopped along the way many, many times and logged stuff. So I wouldn't have just written all this code straight through. But I wanted to kind of see if we could build the whole algorithm. I don't know if it's actually going to work or not first try. But it's the idea is, though, now the done is going to keep growing each time through by these ready people. Everybody who's either their already parent is done or they don't have a parent, they're going to go in the done array. And then we're left with everybody off the, with the array starts with people who are definitely not ready yet. So we rotate one to the end and then we recurse with rotated remaining and the next, and the growing cache as we go. I don't know if this is going to work or not, but let's see. I'll run it once. And given the time, if it doesn't work, it's going to just have to be a puzzle for you to solve because I don't have that much time left. And I got to show you one more thing that I had saved for the very special ending of this study group. All right, here we go. And run it. Do I have any more? I don't want any more schedules in here. Oh, shoot. I had the lineage still there. Yeah, it looks like it did the lineage. And it didn't do... Oh, I didn't put any logger at the beginning of the resequence. So it might just be super slow. You can usually tell, though. And it doesn't look like it's super slow on my other screen. Oh, here we go. Finished 5,000. Okay, it thinks it finished. So I'll delete this scheduler in case I need to rerun it. But we could actually go see the results. I'm going to stop Mule. And sequence.csv. Uh-oh. I'm all in suspense. Let's see. Well, what I do see is we have 5,000 people. I would have to kind of do a spot check or something, but here's the invite code and here's the referred. So the only two people, these two were definitely referred by the first guy, right? So it put these two after the first guy. That was good. So he's going to be inserted before they get inserted. That's pretty good. This one, BUL. Yeah, this one was inserted. Yeah, it worked, right? This guy was right after the one before. Okay. That worked pretty well. I'm kind of surprised it worked on the first try. But anyway, I'm not going to save it. Let's see. Cool. This function, I think what I want to do is take the function we just wrote live and put it. This is a tail recursive function. I'm going to put this in the actual this lesson here. So what I'll do is I'll put another page here. So this is, we'll add this so that you can all get to it. We're going to add a heading 2, example recursive function from live session, like that. And then we'll make a little code block and put it in there. Cool. And then how do I save? Where's the save button? Save. So now you guys have that code we just wrote on the same lesson where you download the sample data. Yeah, so that was really as far down. I wanted to make sure that we got to see the difference between basically any kind of recursion, which is just anytime you have a function that calls itself. This one is not tail recursive. If I put tail recursive on it, it's going to give me an error because it's not tail recursive. That's because it needs the return value here to add to 1. It needs to remember, okay, when I get the return value, then I have to add 1 to it after I get the return value. So if you use the return value for anything instead of directly returning it, your function's not going to be tail recursive. And that's only necessary sometimes. You don't need tail recursive anyway most of the time. So when we did rank, we didn't need tail recursive, and who cares? But there's times that you do need it because of limitations in the DataWeave runtime. It only allows you to recurse 256 times. It runs out of stack. So if that happens, you do need to sometimes you need to make your recursive function tail recursive, and this one is. This one's tail recursive because all it ever does is directly return the call, the recursive call. It doesn't do anything with the result. It just returns it straight away. And that means that the runtime can optimize the way it executes, and it doesn't have to remember anything that went before when it recurses. It doesn't have to keep any state. So tail recursion it's a way around the limitations of your DataWeave runtime. So sometimes you're forced into doing tail recursion. You never care otherwise if it's tail recursive or not. This one, I just wrote tail recursive because that's how I could think about it. And that's really the limits of the recursion lesson. But in the process of preparing it, I discovered I finally taught myself this whole side of the DataWeave command line called spells that I'm going to show you at the end of the lesson. Now, before I transition to that, it's nothing to do with recursion. So does anybody have anything you're left with, anything you want to see how it works about doing recursion in DataWeave? That's really the core of the lesson, was recursion in DataWeave. Don't see anything in the chat. Oh, Max put some stuff. Tested in DataWeave Playground. That was like 5 minutes ago. How did I miss that? On a small data set. I wonder how the performance would compare. Referral counts. Okay, you got the referral counts for everybody. So you pre-compute how many referrals everybody has. Customers group by, yeah, so the group by is a heavyweight. That's the question, is how the group by would scale. Right? And then that's still going to get you, what does get referral details?
It's
It's just a function like to find the referral. I couldn't paste it in the chat.
Yeah.
It has a character limit.
Oh no.
But yeah, but like imagine you would go over the list again and find the refer details.
Yeah. Yeah. So that'll give you one level up, right? That'll give you the guy who referred you for everybody.
Yeah.
And how many you referred to. So it kind of gives you everybody's invite story, right? Who referred you and how many people did you invite? Yeah. I could see that being useful for like a score or something. Maybe we reward them some stuff for referring so many people. I bet you could do another leap. You could do another hop and get when they referred them. So you could see how many did they refer within a week and 2 weeks and 3 weeks and 4 weeks. Yeah. Thanks, Jake. See you later. Is everybody dropping for class? Uh-oh. Well, let me show you the special spell thing. I have it in Visual Studio Code. Bye, guys. Watch the recording for the spells if you want to be wizards. Let me show you the DataWeave command line. There's a DataWeave command line execution environment, and I ended up needing it for this because DataWeave is not multi-threaded. And I had a very slow process, which is so slow that this entire session, I ran it for 25,000 rows, and it's still going. That's how slow it is. I had some kind of, I don't know if I can optimize it some more, but when it does 25,000 rows, the generation process for those customers is pretty slow. So I wanted to be able to run it in parallel more than once. So the way I did that was a little bit of bash magic and DataWeave spells. DataWeave has this feature. DataWeave command line has a feature called spells, right? So if I go to the history, there's me running a spell 5 times in parallel. So I could use 5 different cores of my laptop to generate pages of customers instead of waiting for one process to finish, right? So what is a spell? A spell, let's make one. DW spell create example. You can make a spell like this with the DataWeave command line. And you want to be in a directory where you might have more than one spell because it's going to make subdirectories. And the DataWeave team calls that a grimoire. That's something I'm still learning about. So you create a spell like that, and it makes a directory called example. And what I found is, here's my example directory. It just puts a source directory and a main.dwl there. So like I could just put, 1 to 100 map random. So this is like bunch of random numbers, right? And output application/JSON. There we go. So there's a little spell, and I could put whatever I want in that main.dwl. Yeah. So what I can do is I can run that spell like this, dw spell -l, because what I found was spells can be run locally with a -l. Otherwise, there's a place in your home directory where you clone other people's, so you can run each other's spells. So I can have spells and you can run my spells. I can run your spells. That's what a wizard is in the DataWeave command line. We can publish our spells on GitHub and use each other's spells from the command line like this. And you register who you want to use in a different way. So if you just want to run your own local spells, you use -l, right? So dw spell -l example. And there's my numbers, right? Because I have the directory example here that DW spell created, I can run the spell that's in this. Whatever I put here runs. So it gives me like a neat way to run DataWeave. Now, why would I go through the trouble of making spells? I could always just run a script. Well, spells, here's the one I used to generate my data. Spells can have dependencies. So I was able to use a DataWeave dependency from Maven, which was the data generator I built. And my spell can use a dependency, any dependency I want, and run code from the dependency. So it gives me a way from the command line to use any DataWeave stuff I write and script it. Spells are like little scripts that let you run any DataWeave with any command lines. I made one for the lineage, right? So there's my lineage function. And I used a dependency, right? A study group dependency here, right out of my local Maven repository, right? And ran that function from the command line with dw spell -l. Now the part I'm still learning, and I didn't look at it before the study group, is how do I make my own grimoire, put it on GitHub, and you guys can use mine. So probably Integration Quest is going to make a grimoire, and I'm going to make a grimoire, but we can share DataWeave with each other through this spells thing, which is just a command line feature. There's no way to use that in Mule, but yeah, that's the extra bonus thing I wanted to add here at the end. So, all right, any comments, questions, or observations about all this? This was what I had for this week's study group. I had a lot of fun preparing it. I'll tell you what. It was writing that generation library for the customers was a lot of fun.
Yeah, that was black magic. Thanks, Ryan.
You're welcome.
I wonder, like, do you know why DataWeave is single-threaded, or is it? I mean, it's JDK based, right, or JVM based? So why not like using multi-threading?
It seems like it could. I don't know, and I know who to ask. There's a DataWeave Slack. Thanks, Elias. Yeah. I could ask Mariano. The guy who writes it is Mariano Ochoa. I don't know why it's single-threaded. So when I wanted to, I mean, I guess you'd have to, in the language, you'd have to indicate what function to run multi-threaded, right? Maybe map could automatically multi-thread at least, you know.
Well, like you can write DSLs based on like for your based on JVM, right? So Kotlin is a DSL, one could say, but Kotlin is not single-threaded, definitely.
Yeah, it seems like a big limitation.
Yeah,
I don't know why.
Okay.
Yeah. All right. Well, I hope everybody had fun. We'll see you at the next study group. I'm gonna stop the recording. We don't have to all get